Hi, my name is Allison Reynoso, and today I'm going to be talking about the UH-60 Automatic Flight Control System, also known as the AFCS. Just some background, the UH-60 is a Sikorsky helicopter, also known as the Black Hawk, which is a versatile twin-engine medium-lift helicopter and it is actually the chosen main tactical helicopter used by the United States Army. Okay, so what exactly is this? Well, the ACFS enhances the stability and handling qualities of the helicopter. It is comprised of four basic subsystems: the stabilator, stability augmentation system, trim systems, and the flight path stabilization. Stabilator system improves flying qualities by positioning the stabilator by means of electromechanical actuators in response to collective airspeed, pitch rate, and lateral acceleration inputs. The stability augmentation system provides short-term dampening in the pitch, roll, and yaw axes. Trim and FPS system provides controls positioning angles and force gradient functions as well as basic autopilot functions within the FPS being engaged. This is just a broad term of what it is to help to explain it all, but of course in the next few slides we're going to break it down to make it a little bit easier. Okay, let's break this down even further. So what exactly does this do? Well, it enhances flight stability, precision, and reduces the pilot workload. So I've never flown a helicopter, but we all know there's, a little bit more accesses, and helicopters are actually inherently unstable. So this will help it to become more stable and to help reduce that workload for the pilot. It automates several flight control functions and assists in both manual and autopilot. And above all, which is always helpful, it makes flying safer. Components of the AFCS include the stabilator control system, the stability augmentation system, trim system, and flight path system. In the next few slides, we will explain what each one kind of has its role in. So our first component of the automatic flight control system is the stabilator control system, which aligns stabilator and main rotor downwash in low speed flight to minimize nose up altitude to minimize downwash, minimizes pitch deviations from pilot inputs, and decreases angle of incidence with increased airspeed to improve static stability, and helps with side slip to pitch coupling to reduce susceptibility to gusts, and provides pitch rate feedback to improve dynamic stability. So the helicopter has a variable angle of incidence stabilator to enhance handling qualities. The automatic mode of operation positions the stabilator to the best angle of attack for the existing flight conditions. After the pilot engages the automatic mode, no further pilot action is required for stabilator operation. And because two stabilator amplifiers receive airspeed, collective stick position, and pitch rate and lateral acceleration information to program the stabilator through the dual electric actuators. Our second component is the stability augmentation system, or known as the SAS. You have the SAS1, which is the analog, and it is independent of the AFCS and provides redundancy. Now, also you have the digital SAS, which is the second one, which is operated by the SAS and or the FPS computer, and provides stability in the same axis that is using those same actuators. And it provides overall dynamic stability in pitch, roll, and yaw channels. This next component is for the trim. And the trim is the collective trim, which adjusts collective pitch settings. Cyclic trim adjusts cyclic control for stability and comfort. And then yaw, which adjusts tail rotor settings for yaw control. Now the FPS provides 100% control authority using trim actuators. All actuators operate at a limited rate of about 10% per second. They are self-limited and also limited by the computer. All actuators contain override springs, which allow a 100% override of trim from the pilot and provides a breakout in gradient forces at controls. Next, you have the flight stabilization path. This is what your autopilot is and what we pretty much always think of, like these automatic flight controls, for me especially, because like, you know, we have the G1000 and this is what's holding our pitch, trim, and all of that. And this is kind of what this is. So it holds the roll altitude, holds pitch and altitude, airspeed, and holds heading or automatic turn coordination. And it operates by trimming cockpit controls. The trim must already be turned on, and the boost servos must also be on for proper yaw channel operation. Again, and this is redundancy, that there is always 100% control authority, which we see that also with the G1000, that we have to disengage and or when we first do it, when we first turn it on, you have to ensure that you can overcome that autopilot. We all know there's been plenty of wrecks due to autopilot and not using it correctly, so that 100% control authority is very important. But there is a limited rate of response, and the maximum response is limited to 10% per second. And one SAS must be turned on to provide the rapid response required for short-term stability. Now, of course, there's always going to be failures. It could happen at any time, and there are common failures with each component. There are a lot of moving parts, such as actuators and clutches, that may burn out. So, of course, when you start putting advanced electronics onto any airplane, you have to think how cost prohibitive that it is to, you know, either get it fixed or maintain it, and each part needs to be done appropriately. But just like any other thing, the risk versus the outcome is what really matters. With this, it's going to provide overall stability and reduce pilot workload, but that doesn't take it off completely from the pilot. A failure can cause deviation in flight path, or overall cause a period of instability. It is the pilot's job to still be using any kind of situational awareness to make sure they are not deviating from their flight path and or that they're getting into themselves into an unusual attitude. And within the helicopter and the way it works, there's always going to be warnings of redundancy. And with the UH-60, pilots must have complete pilot override. And from what I was reading of the system, that within any of the components that pilot will always be able to use that, the ability to have the override. Now I want to talk a little bit more about the actuators. So there are 3 actuators provided for the pitch, roll, and yaw channels. They link the SAS electronic components to the helicopter's mechanical flight system, and they are mounted on the transmission deck at the pilot assist servo. They are operated via hydraulic pressure and or electrical inputs coming from your SAS or FPS computer. So you can see that if you have I didn't mean to actually click to go into the next slide, but that's okay. I just want to follow up by saying that there are a lot of moving parts, a lot of electronics, and so failure, it can happen. But again, it's just the pilot's job to make sure that they are maintaining situational awareness and that they know how to properly train for using the AFCS, so that if they do lose it, they can still maintain that stability within the helicopter. And as for this slide, I am a very visual person. Just talking about it, I don't think I would ever understand it. So I found that this video is very helpful. You can click on it and watch it as well. And then last but not least are my references. And for this, I will say that the most helpful thing to do this project and to understand it was this first, or I guess the last one. It's the United States Army Aviation Warfighting Center, from the Warfighting Center, about the AFCS. They did a really wonderful job of explaining exactly what it is and how it works and what to do in case of failure. And that was really amazing. So I hope you enjoyed this. Thank you.